Hello, my name is Luciana Carrion, and this is Project 2. Starting off with our buffer circuit, our switch must be on for the LED to be on. As we can see, our switch is not on, which does not allow the current to flow from the LED back into the power supply, leaving it off. But with our switch on, we can see that the current will flow through the LED into the transmitter and back into the power supply, powering on the LED. When we have our buffer circuit built, we have a 2K ohm resistor in parallel with a 330 ohm resistor. Our 2K ohm resistor is connected to a switch on our right side. On the left side, the switch is connected to the transmitter's base. The transmitter's emitter is connected to ground via jumper, and the transmitter's collector is connected via jumper to the LED. We can see that when our switch is off, the LED is off, and when the switch is on, the light is on. Next up is our NOT circuit. In here we can see when our switch is off, the light is on, and when the switch is on, the light remains off. Here we can see the current when our switch is off. You can see that most of it will be going through our 330 ohm resistor into the LED back into the power supply, turning on the LED. Then we can see our current when our switch is on, and most of it will be going towards the switch, into the transmitter, back into the power supply. Very little will be going towards our 330 ohm resistor into the LED. It's not enough to power it on, so the LED will remain off. On our breadboard, we can see our NOT circuit has a 2K ohm resistor and a 330 ohm resistor in parallel. The 2K ohm resistor is connected to our switch on the right side, and our switch's left side is connected to our transmitter's base. The transmitter's emitter is connected to ground via jumper. The transmitter's collector is connected to both the 330 ohm resistor and the anode of the LED, and the LED is then connected via jumper to ground. Here we can see that when the switch is on, the LED is off, and when the switch is off, the LED is on. Next, we have our AND circuit. Our AND circuit says that both switches need to be on to power the LED. Here we have a case if one switch is on and the other's off. We can see that our current will flow through one switch, but stop at the other. This will prevent the current from running from the LED back to the power supply, so the LED will remain off. When both are on, we can see that the current runs through both transmitters from the LED into each and back into the power supply. This means that the LED will turn on. On our breadboard, we have a 2K ohm resistor, another 2K ohm resistor, and a 330 ohm resistor all in parallel. Our 2K ohm resistors are connected to their respective switches on the right side, and the switches have a transmitter connected on the base on their left side. The transmitter on the far left has its emitter connected to ground via jumper and its collector connected to the emitter of the second transmitter via jumper. The second transmitter then has its collector connected to the LED via jumper, and the LED is connected to the 330 ohm resistor. Here we can see that if we push one switch, the LED will remain off. If we push the other, the same thing happens. But if we push both at the same time, the LED will then be powered on. Next is our OR switch. On our OR switch, at least one switch needs to be on to power the LED. Both switches can also be on and it will also power on the LED. We can see that when one of our switches is on, the current will still find a way back into the power supply while also passing the LED, turning on the LED. When none of our switches are on, we can see that the current gets trapped and does not make its way back into the power supply, leaving the LED off. Here we have a similar setup to our AND circuit. The only differences are the transmitter on the far left has its collector connected to the LED on its cathode side, and the emitter of our second transmitter is connected to ground. Here we can see that if we push both switches, the LED will turn on. If we push either switch, the LED will also turn on. The LED will only remain off if none of the switches are active. There are 4 additional switches that we can test using the Arduino. The first one is the NOR. Our logic gate says that both switches need to be off for the LED to be on. If any or both are on, the LED will remain off. Our pin sequence for this one is 0, 1, 1. Next up is the N AND. Our logic gate says that both switches need to be on for the LED to be off. If any or both are off, the LED will remain on. Our pin sequence for this one is 1, 0, 1. Next is our XOR. Our logic table says that only one switch needs to be on to turn on the LED. If both are on or off, the LED will remain off. Our pin sequence for this is 1, 1, 0. Next and lastly is our XNOR. Our logic gate says that if one switch is on, then the LED will remain off. Both switches need to either be off or on for the LED to be on. Our pin sequence for this is 1, 1, 1. On our breadboard, we can see our switches are connected to our 2K ohm resistors that are in parallel with our 330 ohm resistor that's connected to our LED. All these components are connected to our Arduino, and our Arduino is connected to our laptop where we will be uploading the code. And on top we see our pins that are responsible for our pin sequence for our respective circuits. These are the 4 sequences that we are going to test: the NOR, N AND, XOR, and XNOR. Their pin sequences are right beside them, and we're going to upload this and mess with the pins on the board to create those respective circuits without having to change anything on the board. Here we can see our NOR switch. Our pin is 0, 1, 1, and here we see that if we push either or both switches, our LED will turn off, otherwise it will stay on. Here we have our N and our sequence is 1, 0, 1. Here we can see that pushing either switch will not turn off the LED. The only way that the LED will turn off is if we push both switches down at the same time. Here we have our XOR. Our pin sequence is 1, 1, 0, and our logic table dictates that pushing either switch down, as we can see, will turn on the LED. Otherwise, the LED will turn off, even when pushing both switches down. And last is our XNOR. We can see our pin sequence is 1, 1, 1, and the LED remains on either when both switches are off or both switches are on. Pushing either switch will cause the LED to turn off. That concludes my presentation on Project 2. Thank you.